Good evening, class 8 and 9, especially 9. Unit Sound, Lesson 6, Standard 9, Part 3. Question number 1. First of all, today we are going to deal with some definitions, noise pollution and solution, and some scientific reasons. Question number 1 is very short question. Pitch. Pitch is the shrillness or flatness of sound. Example: high pitch, low pitch, medium pitch, and extra high. Extra high pitch. Shrillness. Shrillness means sharpness or flatness of sound. Sound shrill छ कि फ्ल्याट छ भन्ने कुरा यसले देखाउँछ. डिपेन्ड्स अपन क्वालिटी. Pitch, shrillness or flatness of sound. Example: high pitch, low pitch, medium pitch, and extra high pitch. Another, sound intensity, just like luminous intensity. Sound intensity, see, you have to know 1 second and 1 square meter area. Sound intensity, it is the rate of flow of energy, that means sound energy. When I say rate, means 1 second, not necessarily. Rate भन्ने बित्तिकै 1 second भन्ने बुझौँ. It is the rate of flow of energy, sound energy, per unit area. How much energy is flowing in 1 second in 1 square meter area? That is sound intensity. Its SI unit is watt per square meter. Short form, watt per square meter. What is it? In 1 second, how much energy is flowing? That is sound intensity. Another, threshold of hearing. Threshold of hearing. Have you heard threshold of hearing in politics also? In politics, threshold लगाउनु पर्छ. यसलाई threshold लगाउनु पर्छ. What is the minimum? Minimum कति भोट ल्याएपछि त्यो threshold हुन्छ? त्यस्तो पनि हामी हुन्छ. तर यहाँ चाहिँ अलिकति फरक छ. Threshold of hearing. त्यो हियरिङ हुनलाई मिनिमम साउन्ड इन्टेन्सिटी कति हुनुपर्छ? जुन साउन्ड इन्टेन्सिटी मान्छेले सुन्न सक्छ. 1 किलोवाट चाहिँ हामीले सुन्न सक्छौँ. थ्रेसहोल्ड अफ हियरिङ, समटाइम्स 0 डेसिबल. बट जनरली वी हियर द साउन्ड 50 to 80. 50 देखि 80 or कहिले 60 to 80 पनि भन्छन्. थ्रेसहोल्ड अफ हियरिङ, इट इज द minimum sound intensity which can be felt or perceived. PERCEIVED, perceived. If you are confused to write down this word, you can write experienced or felt, which can be perceived or experienced or felt by a normal human ear. Here, normal human ear, not special type of ear. Some ears are abnormal. They can hear very low sound also and very high sound also. But here, normal, healthy threshold of it is the minimum sound intensity which can be perceived, experienced, or felt by a normal human ear. Question number 1. Pitch, sound intensity, threshold of hearing. Amplitude and others already written. Question number 2. See, mention some ways to solve sound or noise pollution. Here, instead of writing what is noise pollution, because it is very easy, noise pollution is the addition of unwanted sound to normal sound. Some sources are very loud sound, horn, car horn, old factories, old vehicles, and unnecessary advertisement are some of the causes of noise pollution. What are the effects? Bad effects. It is very difficult to hear, no concentration, and some people feel irritation, rheumatism. High blood pressure is also caused by noise pollution. You can write down uh, what is noise pollution, what are the causes, and what are the effects. But here mention some ways to solve sound or noise pollution. It is very easy, very necessary to solve noise pollution. Noise pollution can be solved by the following ways. Many people are confused. यो noise pollution भन्दाखेरि अब afforestation is one. यो पनि बोट बिरुवा लगाउनु के हुन्छ भन्दाखेरि plants also absorb unnecessary sound. The leaves absorb unnecessary sound. Plantation in urban areas. You know how plantation, the especially leaves of the plants absorb unnecessary sound, and anyway sound pollution or noise pollution is reduced to some extent. Another is old vehicles should be replaced by sound free vehicles or electric or solar vehicles. One thing, एउटा के गर्नुपर्छ, प्लान्टेसन वृक्षारोपण कार्यक्रम गर्ने. ओल्ड भेहिकल्स पुरानो खालका यो भेहिकलहरू छन्, सवारी साधनहरू छन् भने त्यसलाई हटाउनुपर्छ, रिप्लेस गर्नुपर्छ. कसले भन्दा बाई साउन्ड फ्री भेहिकल्स, साउन्ड साइलेन्सर राखेको, or electric or solar vehicles. They may be expensive at first, but they are pollution free, eco friendly. Question number 2. Question number 2, 3. Residential areas. Residential areas should be far from the factories, airports, and cinema halls, etc. They or sometimes advertisement programs should not be done too much. Residential areas where people live should be far from the factories, airports, cinema halls, etc. Another, silencers or other things, earplugs, silencers or earplugs should be used, earplugs, which reduces sound pollution. Another is public awareness, loudspeakers or loud advertisement should be discouraged, especially in marriage ceremony or some other functions. People, some people, not all, I don't blame all, सबैलाई म दोष लगाउँदैन, केही मान्छेहरूले चाहिँ लाउड स्पिकरबाट सबै दिनभरि नै हल्ला गर्ने, अरूलाई सुत्न पनि नदिने, अरूलाई डिस्टर्ब गर्ने खालको लाउड स्पिकर, लाउड एडभर्टिजमेन्ट, विज्ञापन गर्ने धेरै ठुलो आवाजमा, यसलाई डिस्करेज गर्नुपर्छ. एनुदर पब्लिक अवेरनेस इज necessary. So if you do, they are some of the solutions of noise pollution, because noise pollution is very harmful. It disturbs our health, no concentration, it increases blood pressure, no concentration, etc. So sound pollution must be reduced. Question number 3. Now question number 3. Here I'm going to write down some questions. State scientific reasons. State scientific reasons. Sound can't travel through vacuum. Especially if you go to space or on the lunar surface, we cannot hear sound. Sound cannot travel through vacuum. See, sound is a mechanical wave, means which needs a material medium to travel. It shows that without medium, either solid, liquid or gas, sound cannot travel through vacuum. Its speed in vacuum or space is zero. So you can write down sound can't travel through vacuum. In the same way, to talk in space or on the lunar surface, we need an electronic device like walkie-talkie. A number. And other questions are there. Sound cannot travel through vacuum. Lightning. What is the difference between light and sound? Lightning reaches the ground much faster than thunder, although they occur simultaneously at a time. Especially in rainy season, we experience this, we feel this experience. So rainy season, lightning. What is the speed of sound and speed of thunder? First of all, you have to write down. The speed of light or lightning is 3 into 10 to the power 8 meter per second. That's very high. But that of thunder means sound, is only about 332 meter per second. Very less, very low. Light speed is very high, 3 lakh kilometer or 30 crore meter per second, whereas the sound speed or thunder speed is only about 332 meter per second. So what is the difference? Very high and very low. So first of all, what comes? Lightning comes. Then thunder comes little bit less. पहिला लाइटिङ अर्थात् यो लाइट बिजुली चम्किन्छ, त्यसपछि मात्र केही समय आफ्टर फ्यु सेकेन्ड्स ओन्ली वी क्यान हियर द थन्डर. पछि मेघ गर्जेको आवाज चाहिँ अलिक केही समयपछि आउँछ. पहिला झिलिक्क आउँछ, त्यसपछि मात्रै यो मेघको आवाज आउँछ. फर्स्ट अफ अल lightning travels, first of all lightning, then only thunder. So lightning reaches the ground much faster than the thunder. It is due to the difference in a very high difference in velocity. Another, sound absorbers like cotton, wall, paper, cotton. Okay, can give examples? Cotton, etc. Sound absorbers are used on the walls of a cinema hall or lecture hall. If you say cinema hall, you have to say to hear the dialogues and music. If you say the lecture hall, yeah, lecture hall bhayमा to listen to the lectures. Music भन्यो भने त्यही अनुसार लगाउनुपर्छ. Sound absorbers are used on the walls of a cinema hall. Why? किन होला? The answer, question number 3C. Answer, sound absorbers are sound absorbing materials. Sound absorbers are used on the walls of a cinema hall. Cinema hall, another equivalent word is movie hall. Why? To reduce echo or reverberation, both. To reduce echo or reverberation. Sometimes in cinema hall echo is heard, but sometimes reverberation is also heard. कहिलेकाहीँ प्रतिध्वनि इको, कहिलेकाहीँ रिभर्बेसन, धेरै गुन्जायमान आउँछ, भेरी लाउड साउन्ड. टु रिड्युस इको or reverberation and listen to the music and the dialogues clearly. सिनेमाको कलाकारहरूले बोलेको कुरा प्रष्ट सुनियोस् भन्नको लागि. Who speaks? The artists, like actor, actresses, villains, their relatives. I mean, hero, heroine भन्छौँ. We say actor and actresses. The dialects of actors, actresses, and villains and their relatives. Question number D. At night and in the daytime, what is the difference? So you can imagine sound can be more distinctly, means clearly. Distinctly means clearly heard at night than in the daytime. Possibly this may be the last question for numerical. Sound can be more distinctly or clearly heard at night than in the daytime. दिउँसो भन्दा राति प्रष्ट आवाज सुनिन्छ. State two reasons. Reason number one, at night, what is more? Humidity is more. Humidity is more, but sources of sound. That means sound absorbing materials, sources of sound, or and sound absorbing materials are what? Sources of sound absorbing materials are less, or sound producers are more, less. Sound absorbing materials are fewer. Or number one, more humidity, and another is sound producers or disturbers are less in number. It is better to write at night humidity is more. पानीको मात्रा हावामा आर्द्रता ह्युमिडिटी बढी हुन्छ. अर्को साउन्ड एब्जर्बिङ मेटेरियल्स, साउन्डलाई एब्जर्ब गर्ने मेटेरियलहरू के हुन्छ? थोरै हुन्छ. साउन्ड एब्जर्बिङ मेटेरियल्स आर फ्युअर इन कम्पेरिजन. सो sound can be more clearly heard at night than in the daytime. That's question number 3. Question number 4 is prove that E equal lambda. How to prove? Without wasting time, V for velocity, lambda wavelength, and F frequency. Solution of this problem is as follows. Let V for sound speed, speed of sound, distance travel per unit time, lambda wavelength, F frequency, and capital T is time period, time taken by the wave to make one complete vibration. एक one complete vibration गर्नलाई कति टाइम लाग्छ त्यो क्यापिटल टी हो. हाउ टु प्रुभ? Question number, that is question number 4. Prove that. See, we know left hand side speed equal distance travel per unit time. That is, speed is defined as the distance travel per unit time, because lambda wavelength is the distance travel. And what is the time? T. You can write this as T, lambda into 1 by T, lambda into F, because 1 by T equal F or T equal 1 by F. In 1 second, it makes F vibration. And 1 by T, 1 by time period is frequency. Frequency is the number of complete vibrations made by the body in 1 second. Lambda F. Therefore, P equal lambda F. Proved. If you know speed equal lambda into F, in the same way, you can derive as follows. Lambda V by F and F equal V by lambda. Just derive it. Question number 4. Last question for today is question number 5. See, find the, instead of numerical, I will solve one type question. Find the minimum and maximum wavelength of a sound wave which can be heard by a normal human ear. What is this sound called? You sound like human, is it? The sound which can be heard by human beings is called audible sound. Yes, audible sound. हामीले देखा हुन्छ नि त्यो रेडियोहरूमा टिभीमा अडियो भन्छ वी युज अडियो. वाट यु मिन बाई अडियो? विच क्यान बी हर्ड, जुन सुन्न सकिन्छ त्यसको चाहिँ निकाल्नु पर्यो. फर दिस पर्पज यु हेभ टु कन्सिडर टु constant quantities. Number one, speed of sound 332 constant, and what is the minimum frequency and maximum frequency. You know, minimum frequency maximum wavelength, and maximum frequency minimum wavelength, just inversely proportional. You have to know that lambda is inversely proportional to frequency. See, यो फ्रिक्वेन्सीको अगाडि हामी के भन्छौँ? हाई एन्ड लो भन्छौँ. हाई फ्रिक्वेन्सी, लो फ्रिक्वेन्सी. तर फर वेभलेन्थ वी डोन्ट से हाई वेभलेन्थ एन्ड लो वेभलेन्थ, वी से long wavelength and short wavelength. For wavelength we say long and short, long, short and medium. For frequency we say high frequency, low frequency. Wavelength को लागि long wavelength and short wavelength. Solution: to find the minimum wavelength and maximum wavelength. Minimum and maximum wavelength. First of all, solution: V, speed of sound is always constant, say 332 meter per second. To find minimum wavelength, you have to take maximum frequency. Maximum frequency. What is the maximum frequency? F max 20,000 hertz. Maximum frequency is 20,000 hertz. Calculator, right? I need a calculator. See, generally students need a calculator to solve this problem. Speed 332 meter per second and maximum frequency audible sound 20 hertz to 20,000. You see range more. So maximum frequency F max, when the frequency is maximum, wavelength is minimum. Minimum wavelength or this lambda min equal what we know. Lambda min, यो minimum होला frequency, maximum हुनुपर्छ F max, because they are inversely proportional. V 332 meter per second, maximum frequency is 20,000 hertz. 20,000 hertz. So what is the minimum wavelength? I will just show you. You just use a calculator. 332 divide by 20,000. See, 0.0166. 0.0166 meter, nearly. You say nearly, or you can change it to centimeter. 0.0166 meter, very low or short wavelength. Minimum wavelength means shortest wavelength is 0.0166 meter. यो भन्दा सानो wavelength भएमा सुन्न गाह्रो हुन्छ. Minimum wavelength, maximum frequency, minimum wavelength. Another is minimum wavelength. What is the minimum frequency? Minimum frequency, we notice that minimum frequency F min equal only 20 hertz. If the frequency is minimum frequency, maximum wavelength, lambda max is the notation. Lambda max means maximum wavelength. Lambda F min means minimum frequency minimum, wavelength maximum, frequency maximum, wavelength minimum. just inversely proportional. What is the formula? We know lambda max, maximum wavelength is velocity by minimum frequency. Velocity is 332, minimum frequency is 20 hertz. Just I show you 332 by 20. 332 divided by 20, and it is 16.6 meter. 16.6 meter nearly. So the answer is speed is 332 meter per second, maximum frequency 20,000 hertz, minimum frequency 20 hertz. So when the frequency is maximum frequency, minimum wavelength, V by F max. Lambda mean minimum wavelength equal speed upon maximum frequency. Speed 332 meter per second sound wave, and maximum frequency 20,000, or divide it 0.0166 meter is the minimum wavelength that can be heard by human beings. And what is minimum frequency of audible sound? 20 hertz. Below 20 hertz infrasound, above 20 hertz 20 kilohertz ultrasound. But here minimum is 20 hertz. Maximum wavelength lambda max equal what? We know lambda max equal V by lambda mean 332 by 20, 16.6 meter nearly. So maximum frequency minimum wavelength, and minimum frequency maximum wavelength. This was for today, and next time I will solve if frequency is more, wavelength is less, and if frequency is less, wavelength is more. So frequency and wavelength are inversely proportional to each other. You have to know this. This relation is very important. See, wavelength is inversely proportional to frequency, and frequency is inversely proportional to wavelength if the speed of sound is constant. When wavelength increases, frequency decreases. When increases, it decreases. Decreases, increases. But the product is the same. अथवा इन नेपाली यो ल्याम्डा बढ्दैछ भने फ्रिक्वेन्सी घट्छ, घट्दा बढ्छ, बढ्दा घट्छ, तर यसको प्रोडक्ट सेम हुन्छ. When lambda increases, frequency decreases. When lambda decreases, frequency increases, but their product is the same in all cases. So the speed of sound is constant in air. Okay, this much for today.